an invaluable asset for industry. Vibration measurement and frequency analysis have become the essential tools for quickly and accurately evaluating the condition of machinery before and after repair service, resulting in dramatic reductions of premature machinery failures. The Model 1900 Vibration Analyzer from CSI, the vibration tool for everyone, with the technology to measure vibration levels backed up by spectra and waveform analysis. This analyzer is power-packed with today's finest vibration technology. Let's take a velocity alarm setting. Enter here the vibration alarm limit in inches per second. When the overall signal input reaches this level, an alarm bar is displayed on the screen. A typical value for a pump motor combination is 0.3 inches per second, so enter that, and press the Enter key to save the setting. The same can be done for each of the vibration units. Let's look at the non-vib alarm setting for our example. Let's set the alarm for 35 amps, keeping in mind that it will only show up on the overall measurement. Press Enter to keep the settings and return to the menu. We can save this new setup into memory as the new default, so that when the analyzer is next powered up, it will be ready to make the current measurements without going through the setup again. Let's make some measurements using our new setup. First, we'll make a spectrum measurement and save it to memory. Notice the units say non-vib units. Since the trigger was set for one shot, it made the measurement and stopped so the spectrum is shown with the display frozen. To save this data, press the Save Data key and use the default label. Press Enter to save. To make a waveform measurement, press the Measurement Mode key. We have used this key once to retrieve stored data. Other options under this key can be used to select other types of measurements, as well as turning on and off the trigger and averager. Press the Waveform key, and then the Start Analysis key to make this measurement. Once again, the waveform is captured and the display is frozen with the measurement stopped. Store this data and use the default label. Let's make an overall measurement of the normal running current. Again, press the Measurement Mode key, then the Overall key, and the Start Analysis key. The overall is displayed and flagged with an alarm. When averaging is not enabled, the overall measurement is a scan, meaning that the 1900 displays the measured results as soon as they are calculated. This gives the fastest response to changing signal levels. Freeze and store this data using the default label. Press the Start key to continue the measurement. Press the Averager key to begin averaging this overall measurement. With averaging enabled, the overall average level shown is an exponential average of the calculated values. This type of averaging gives most weight to the latest data and progressively forgets older values. In this way, rapid changes in level are smoothed out, and the displayed value is a better reflection of the general trend of the data. Freeze this measurement and store it using the default label. To use the other options on this Measurement Mode menu, we'll measure the normal motor running current. Press the Measurement Mode key, the True RMS key, and the Start Analysis key. The display is now updating the true RMS value and displaying an alarm. Press Start Stop to freeze the display and again save it using the default label. To make a true peak measurement, press the Measurement Mode key, the True Peak key, and the Start Analysis key. In the True Peak mode without averaging, the results of a measurement are shown in three ways simultaneously. The True Peak hold level, shown on the thermometer scale, is the largest peak seen by the analyzer since the measurement began. The RMS value is always an exponential average, as described for the overall average mode, and reflects the overall amount of signal energy present. The crest factor is the ratio of the peak level to RMS level and indicates how spiky the signal is. If the crest factor is high, 8 for example, then the signal has high-frequency spikes at a high level compared to the average signal. This makes crest factor a good indicator of the early stages of rolling bearing faults, onset of cavitation, and other faults which show up as high-frequency impulsive vibrations. Press the average key to begin averaging the data. When the averager is enabled, the level of display becomes an exponential average peak. The RMS level is still an exponential average, and the crest factor is calculated from the ratio of average peak to RMS. The average peak mode helps in making measurements on a system which is changing gradually over an extended